In today's environment conditions, moisture of the soil plays an essential role in the irrigation field as well as in gardens for plants. Nutrients in the soil which act as food to the plants for their growth are greatly affected by moisture content of the soil. If there is a shortage or overabundance of water, plants may die. At the same time, this data depends on many external factors, primarily weather conditions and climate changes. Soil moisture affects ground structure and thickness and also its temperature and heat capacity. The roots of plants absorb water first, so their condition directly depends on its amount. Ultimately, the soil moisture affects plant growth and yield. Here we have used FC28 resistive type moisture sensor. Some other options may be capacitive moisture sensors which are more accurate. For building this, let's make a block diagram of moisture sensor system. The block diagram consists of FC28, which is the moisture sensor being used in the system, connected to a voltage divider where sensor voltage is generated. The generated voltage is provided to a voltage follower using unity gain amplifier. The output of the amplifier is accepted as input by analog to digital converter, which provides a digitized output to a processor where percentage moisture is calculated. This configuration is very popular in distributed architectures like sensing moisture in a field, etc. Multiple FC28 moisture sensors can be connected to individual unity gain amplifier module, and an analog multiplexer can be used to select the signal into a single ADC. A single microcontroller can acquire the data in multiplexed manner for processing. Modules need to be arranged in the same sequence as the block diagram without attaching them physically. Next, connections have to be identified and made before connecting them. The modules which we require for this application are USB based low noise power supply, 4 differential 8 single-ended inputs with bridges. Here we need to select the input mode in all 4 channels. The third board is the general purpose amplifier with gain set as 1. The fourth board is the ESP32 Rover dual core processor module. In summary, the 8 numbers of FC28 sensors are connected to input board and the outputs are routed to jumpers OI through OP. These outputs are voltages of moisture sensor. They are given as input to the unity gain amplifier board by shorting the jumpers II through IP. Finally, all the outputs will be available in OI through OP of unity gain board. These are taken into the ESP32 processor board by shorting the jumpers II through IP. The microprocessor will sample this through the mux. Our test setup consists of E-LAGORi boards stacked up in the order as previously mentioned. Soil with 10% moisture is taken in a beaker. Moisture sensor is immersed in the soil. The USB of the E-LAGORi board is connected to a laptop with Arduino IDE, and serial monitor is used to view the moisture measured by the FC28 sensors. The reading on the serial monitor can be seen as 10%. The following procedure is followed in order to calculate the percentage moisture. Initially, the soil is heated in order to obtain the dry soil by removing the moisture content. A beaker is filled with known weight of dry soil. Moisture sensor is immersed. The voltage is noted. The moisture sensor is removed. Then 5 ml of water is added and is mixed for uniform distribution, and corresponding voltage is noted by immersing the moisture sensors. These steps are repeated till the moisture becomes saturated. Now a curve is plotted for water added versus voltage observed, and a relation is established and implemented to calculate percentage moisture. Thus we can see that moisture sensor array can be easily constructed using E-LAGORi boards in about 20 minutes. Data can be sent to a mobile using Bluetooth protocol. In the next block we will interface a thermoelectric cooler.
Visit www.e-lagori.com for more details.